Today we're going to look at how to configure a Champion TKO Base and Rover system with UHF internal radios. So let's go ahead and in our Scepter data collector, go down and open up Carlson SurvCE. When Carlson SurvCE opens up, we will have a couple of options as to whether we want to select a new job or continue using our last job. We're going to go ahead when it opens and select a new job. So we go ahead and select that. We tap down in the name field and we just simply give it a name by typing in the field, hitting our check mark, and then hitting our check mark again. Once we've done that, it's going to come up and look at some of the job settings we have in the system. In this case, what I'm really concerned about is my projection. I want to make sure that I'm in the right part of my state and I'm working in Georgia West. The rest of the settings I'm not going to worry about. We've gone over those in other videos and on the Champion YouTube site. We're then going to go to our Equipment tab and we're going to start by configuring our base. So under GPS base, I'm going to make sure that my manufacturer is Champion Instruments, my model Champion TKO. I'm going to go to the Comms tab and I want to make sure it's Bluetooth, and the default Windows Mobile is my Bluetooth type. If I've not done so before, as far as pairing my Bluetooth between my data collector and a GPS receiver, I'm going to hit the wrench and hammer. I'm going to tell it to find the device. My Scepter data collector will now look for any Bluetooth devices in the area and it will provide a list of them for me. We have seen, if you're in an area with a ton of Bluetooth devices, that sometimes you can have issues here. So try to make it an area where there's not a tremendous amount of different devices around that the system may get a little bit confused. Right now it's searching the different serial numbers of the devices, and we see that's actually my Rover, the 3011316. I've looked at the serial number on the bottom of it and I'm waiting for it to come up with a list to tell me what else we've got there. So in this case, our Bluetooth device in our Scepter found two different receivers. 3011316 is my Rover and 102.06148 is my base. So I'm going to highlight that, hit my check mark, and then I'm going to go ahead and tell it with a little Bluetooth icon to bond to it. Now the first time you do this, it comes up and it asks you to set a passcode. And I'm going to go ahead and say yes there, and then type in our passcode of 1, 2, 3, 4. You will always use those 4 if you ever have to do this part, but again, it's only done once and then it'll show up in the list each time for you. Once it's completed the bonding, it says that it has, and you just say done, and then you go ahead and hit the little icon up top with the cable connecting to the receiver, and it should tell you successful connection like it did. We'll go to our Receiver tab. In this place, we're going to put our antenna height. If you were on a tripod, it would vary, but in my case, I'm on a 2-meter pole and a prism pole tripod, so it's 2 meters or 6.5617 feet. We're also going to go ahead and go to our RTK tab. And here we want to make sure we have internal UHF selected. The very first time you come in, it'll say cable or generic device. We want it to say internal UHF. You'll see that our ports are grayed out. We use a standard for that, and so you don't have to ever worry about changing that. We're going to go ahead and hit our wrench icon here. It should now go ahead and try to connect to the internal radio so we can look at what the radio channel is and the wattage. Once it's connected to the internal radio, you see this screen showing your wattage for your receiver and the channel it's on. We have 4 standard channels that are programmed in. We're just going to leave it on channel 1 here. We can also program your FCC radio license channels, which we recommend by law that you get your FCC channels, and at that point you'll have at least 12 channels. We'll go ahead and hit our check mark here. Once we do it, it tells us the device is configured. The next thing we want to pay attention to is the message type. We can receive either RTCM3, CMR, or CMR Plus. Let's set it at CMR Plus. We'll go ahead and hit our check mark. It is now going to ask us how we want to set our base up. Do we want to set it up over a known point, or do we want to set it up over a new position? And so we're going to choose the new position. From known position would give us previously surveyed points. These are local state plane coordinates, or you can read from a file that you surveyed or set up on the day before. But we're going to do from a new position, and here we're just going to go ahead and read from GPS. And so we're going to tell it the number of positions we want to read. Normally I would set this at 99 or 999, which gives us an average over 999 seconds of a quality position. But for the purpose of this demo, we'll just take 10 readings, and we'll go ahead and have the system average those 10 readings together. This will take about 10 seconds, as it's approximately 1 reading per second. This will stay autonomous because our base station is never fixed. Our base station is sending correction data. Make sure here at base configuration that you do not put a broadcast ID. Just continue with your base setup. And once we've continued with it, it'll ask us if we want to save it to a file. By saying yes, it'll suggest the same file as our job name, video.ref. So tomorrow if I came back and set up over this same point, all I would have to do is put my instrument height in and then go ahead and load that video.ref file, and I could continue on and start working. So now that our base is set up, let's go ahead and go to GPS Rover, and we're going to check some of the same settings in GPS Rover. So we want to switch out of simulation, Champion Instruments, Champion TKO, go to Comms, Bluetooth. Let's find our receiver by telling it find device. You see my base is still in that list now, and it will be there forever unless it's deleted. So right now it's going to go ahead and look through for our Rover receiver. Once we've found that, we're going to go ahead and go through the same steps. We're going to pick the receiver. We're going to tell it to have the Bluetooth connect to it. We're then going to go ahead and add it to our device list by putting in our password. This keeps us from ever again having to redo this. It'll always be in our drop-down list for us. Once it connects, we tell it we're done. We hit our little pigtail up here, power going to the receiver, successful connection. And you'll see now in my drop-down list I have my 2 receivers. From now on I can always pick those receivers. Go here, make sure my rod height is correct, and again I'm using a 2-meter pole. A nice feature in Carlson is you can always just type 2M in the fields, and anytime you put that M afterwards, it'll automatically convert the metric to feet. We go to the RTK tab. Again, we want to make sure we're using the right radio. So we want our internal UHF radio. We want to go ahead and check our configuration again with that. So it's going to talk to the radio. It'll come up for us, and we'll have the option to see where we're at. 1 watt, channel 1. On our Rover, it actually always sets it at 100 milliwatts because it's receiving, it's not sending, so the power doesn't have to be as high. Once the device is configured, we want to make sure we're speaking the same message type, and we set the other one at CMR+, so we want to do the same there. We hit our check mark, and our Rover is now configured. So our next step is going to be to go to Monitor Skyplot, and we're going to look and see if we are receiving corrections from our base, and we are. We're receiving them every second. We're fixed already. We see our horizontal and our vertical accuracies are 300ths and 600ths where I'm working. We can look at our satellites, and we can see where they are in the sky. We can go to satellite info, and we can also tell the signal to noise ratios as well as the azimuths and the elevations of the different satellites. Under reference, we can see how far away from us our reference station is. You see here I'm only 2.4 feet away. Let's go back to quality for a minute because I want you to see something here. I'm actually going to go to the position tab now once we know we're fixed, and I want you to see that our ellipsoid elevation is the same as our local elevation. That means I do not have a geoid file loaded for this particular job. So what I want to do is come back out of here, I want to go into my equipment tab. I want to go to the localization area, and then I want to go into GPS. I'm going to pick geoid file, navigate to where I have my geoids stored, and I'm going to pick the geoid file that encompasses the area I'm working in. Now once I've done this and we go back to monitor sky plot, we're going to see two different elevations. So let's do that. Let's go to monitor sky plot, and we see we're fixed. Let's go to our position tab, and right now you'll see that we have a ellipsoid elevation of 889 feet and a local elevation of 985 feet. This is very common for where we're at, about a 100-foot shift total. So at this point we're ready to go ahead and go to work. So we're going to go to survey, and we're going to go to store points. Once in my store point screen, all I simply have to do to take a shot is hit S for store. I can then come down in my description code list, grab whichever code applies to what I just shot, change my point ID if I need to, make sure my rod height is good. If I would like to take a picture with my camera, I could, but we're just going to go ahead and store this. And that's it. Proper procedures we would recommend, though, as opposed to just storing one point, would be to go to your configure and store no less than 5 points at a time and average them. NGS actually recommends 180, so you may wish to follow those guidelines. Again, we just hit store at that point, and it goes ahead and goes through, takes the 5, shows me my averages, allows me then to put a code on them, and I store that point. If I need to take a longer shot for a control, I'll hit A for average, come in, modify the number of points I want, and go ahead and begin taking readings. What we see while it's doing the averaging is we see our standard deviations in our northeast and elevation, as well as the number of satellites and our status. As long as our status stays fixed and we have good horizontal and vertical qualities, we'll see that the number of readings it's taken and the number of valid readings stay the same. If we were to go to float or autonomous, we would see that our readings that it took versus our valid readings would be different. Once the averaging is complete, we get a statistical of how well it averaged and what our average coordinates were. Traditionally, I look down at the bottom numbers here and I make sure they're not too blown out. If they look good, under a 10th, let's say, we hit our check mark. To accept those results, we once again put our code in, whatever we choose our code to be, and we hit our check mark. Once we've completed collecting all the points we need to complete, we can go back to our File tab. We can go to Import, Export. We can export our points as an ASCII file. We simply tell it user defined, point ID, comma, northing, easting, elevation, description. We can tell it a range. Do we want to export all the points or just a few of the points? Let's say we want to do all. We hit our check mark there. We give it a name. It defaults to the job name .txt, and we save our file. Say OK and done. And we can now go ahead and turn off our data collector or exit out of SurvCE. And so once I exit out of SurvCE, it takes me back to the Windows screen. My job is complete, and I can go ahead and turn off the collector and turn off my GPS receiver.